Hello everyone and welcome to this video. In this video, we'll be talking about unit testing in C#. We'll be looking at how to test our code. But first off, a brief introduction. Welcome everyone. This is CodeDynasty Studios and welcome to the YouTube channel. Familiarize yourself by subscribing to the channel and let's get started. In this video, we'll be talking about unit testing in C#. So let's proceed. Here are some of the concepts we'll be reviewing in this video. The first is test-driven development. Then after test-driven development, we'll be checking out the red-green refactor workflow. Then followed by the automated versus manual testing. We'll be looking at the differences between automated testing and manual testing. We will also be looking at unit tests. We will also be looking at integration test and MSTest. MSTest is the one I particularly use. There are many other testing frameworks out there that you can use, which there is NUnit, there is X, there are many other frameworks. I even left a link, sir. I left a link if I am to share the slides later on. I left the link. You can other frameworks you can use in testing. And then lastly, we're checking out the benefits of test-driven development. Let's proceed. So test-driven development, what is TDD about? Test-driven development is the process of writing our test even before we write our actual code. Test. Most times you would see many online tutorials use the word specs instead of test. They pretty much mean the same thing. That is why I kept specs into brackets. Yes, they pretty much mean the same thing. Test and specs, they are used interchangeably most of the times. So test-driven development, all it is about is you writing your test even before you write your actual code. Let's see how we carry out TDD. First, we break our code down into chunks, the smallest pieces of functionality we can. I call chunks, I call what I love to do, what I call chunk of codes is smallest pieces of functionality. You breaking your code down into the smallest possible atom you can. And then next, we write a test for a piece of functionality before we add that code to our code. Even before you are writing your code, you are writing a test for it. That's the second step. Then finally, we add the code to make that test pass. Let's proceed. Next, let's look at the red-green refactor workflow. The red-green refactor workflow, mostly you would see it as RGR workflow in short. The red-green refactor workflow helps us follow best practices for testing. When we use the red-green refactor workflow, we complete 3 phases for each test we write. The first phase is the red, the second phase is the green, and the third phase is the refactor. The first phase is what we are going to be looking at is the red phase. Let's look at the red phase. After writing a test, we first confirm the test we've written is failing. First, to ensure there are no false positives. What's a false positive? A false positive in testing is a test that is passing when it should not be. For example, you wrote a test now and okay, you're like, this test must fail, but it ends up passing, then you have a false positive there. Because why? The test is passing when you're expecting it to fail. The test should be failing because there should be no code in place to make that test pass. The next is the green phase. Let's take a look at the green phase. The green phase, after confirming that the test is failing. So the first one is red, which is that you would write a test. Let's look at it again. Red stage, which is that you will write a test and then you would ensure that that test fails. This is a workflow. You write a test, then you ensure that that test fails. Then after the test fails, you move on to the green stage. The green phase, you would confirm that your test is failing. We write just enough code to make the test pass and run our automated testing software to ensure that the test is passing. In the green stage, you will write just the adequate amount of code to ensure that that test passes. Don't forget, the red phase, you are writing a test and that test must fail so you don't have a false positive. Next, the green phase, after confirming that the test is failing, you've confirmed that the test fails. Now it's time to write the adequate amount of code so as to ensure that that test passes this time around. Then the last stage, which is refactor phase. In refactor phase, after completing the red and green phases, we can optionally refactor our code. The refactor phase is optional in the sense that you can choose to refactor and you can choose not to refactor. And sometimes it might be nothing to even refactor at all. So what do? You don't just end up destroying your code. You just move on if there's no chance for refactoring. After refactoring our code, we need to run our automated test to make sure that all tests are still passing. This is a guide you should always do. Every time you refactor, you must still end up running your entire test so that you ensure that no test is failing. So let's proceed. Then let's look at manual versus automatic testing. First, automated tests. When we write automated tests, we are writing coded tests that are run by software like Jest or MSTest. In this YouTube channel, we mostly make use of MSTest. Yes, MSTest is a testing framework. Like I said earlier, there are other frameworks for testing, which is the X unit, the N unit test, and the likes. So automated tests, when we write automated tests, we are writing coded tests that are run by software like Jest. Jest is mainly for JavaScript. Jest was written in JavaScript, yes. Jest is also a testing framework that you can use if you're a JavaScript developer. And then let's look at manual tests. Manual tests, when we perform manual testing, we are clicking around our application or something similar to confirm that our code is running as expected. Manual tests, you are doing it by yourself. No framework is helping you to do it. No framework is helping you to perform any test. Let's proceed. A unit test focuses on testing a single component of our code. What is a unit test? Unit test is even the main reason for the video, which is, and what does this unit test mean? A unit test focuses on testing a single component of our source code, like a class, a field, or a method. That is all what unit test does. Unit test where we check a single component. It can be a class, it can be a field, it can even be a method. Next, integrated test. An integration test focuses on testing how multiple source code components work as a group. You have tested them units. You've done unit testing, which is testing each component. Now you're about to do integrated testing. Integrated testing would it will combine multiple unit tests and test them. It will combine multiple components, multiple unit tests, and test them as a whole, test them as a group. Typically, a combination of business logic and user interface logic, that is what we call integrated test. For example, an integration test might check that the user can properly fill out the form, submit that form, and be routed to a success page. Routing is just moving around. Yeah. Let's repeat the integrated test. An integration test focuses on testing how multiple source components work as a group. Typically, a combination of business logic and user interface logic. For example, an integration test might check that the user can properly fill out a form, submit it, and be routed to a success page. Moving on, MSTest. MSTest, the testing framework we use to write our unit tests for our C#/.NET in our tutorials within each unit. This is a testing framework that we'll be using to write our. This is a testing framework we'll be using in all of our C# and .NET tutorials. Within each unit test, we can list an expected result. Then our test will let us know whether that test result is achieved or not, just like Jest and JavaScript. MSTest is just one of many .NET testing frameworks we can use. This is supposed to be a link, but it can no longer be a link because of it's a picture now. It can no longer be a link. But if I am using the PDF format of it, this will be a link, and it's a link to take you to many other .NET testing frameworks that you can use out there. So you can visit the MSTest GitHub repo. You don't even really need the link. Just type in Microsoft. Just type in .NET testing framework documentation. You would see it on your browser. Next, let's look at the benefits of TDD. Now, first things first, what is TDD? TDD is test-driven development. It is a process in which you are writing the test first, even before you actually write the actual code. And in TDD, in TDD, we perform what we call the red, green, refactor workflow, RGR. In red, green, refactor workflow, first the red phase. This ensures that your code, you will write the test under the red phase, and then you would ensure that that test fails. If the test does not fail, then you have a false positive. So you have to fix that false positive because false positives are very dangerous. Then the next phase of RGR workflow is the green phase. The green phase is you writing the adequate amount of code to ensure that your test now passes. Then the next is refactor. You check for refactoring, and refactoring is optional. You can choose to refactor, you can choose not to refactor. Now let's look at the benefits of TDD. TDD stands for test-driven development, like you already know. TDD helps us create a plan. By taking time to think through a program, identify behaviors, and tackle the simplest first, we are creating a game plan. We are laying out each step we need to take in detail, which leads to the next benefits. The next, TDD. Benefit of TDD. It's easier to tackle complex problems. Even the most experienced coders that can struggle with approaching complex issues. By identifying and testing the simplest possible behavior at a time, we can take baby steps towards solving bigger problems. Once again, this is just like breaking your code into chunks and then reasoning up from there, as opposed to reasoning by analogy. Benefits of TDD. Let's look at another benefit of TDD. It prevents errors and makes bugs easier to locate. When we implement and test a single behavior at a time, we are preventing errors. Testing each behavior before moving on allows us to spot bugs as soon as they are introduced. Without TDD, we might not spot some of these bugs until they break our application. To make matters worse, if we add more code after introducing a bug, other parts of our application will likely be reliant on our body code. Absolutely. You have made an error somewhere, and then you are now still adding more code into it. It can just, the error at that particular place that you didn't solve might end up filling the other codes that you wrote subsequently after. To resolve this issue, we will need to locate the bug, resolve it, and potentially alter all the work that depends on the buggy code. That's a lot of work. So just use TDD. TDD will help you test a single, TDD will help you test each part of your code. Next, it allows us to create projects faster. TDD helps us. Starting a complex project can be daunting. Yes, it can be challenging. Even if we aren't sure how to code, even if we aren't sure how to code the more difficult features of our application, we can hit the ground running by implementing smaller identifiable functionality as we work. As we work, the bigger picture will come into focus. If it's a complex project, starting it might be very daunting in the sense that you might keep on procrastinating and procrastinating and procrastinating, or you might not even know where to start from. But with TDD, you start from the unknown to the known. You start from the known to the unknown. That is what TDD helps us with. Sorry. Next, new features are built upon reliable code. Another benefit of TDD, by testing functionality as it's implemented and ensuring previous tests still pass. When new functionality is introduced, new features are always built on a foundation of reliable and tested code. The next, it keeps our code dry. DRI stands for do not repeat yourself, or don't repeat yourself. DRI in the sense that DRI is just a very, very easy refactoring approach. You are refactoring your code whenever you make your code dry. You are avoiding repetition. You are avoiding repeating yourself over and over and over again. You are avoiding repeating yourself. By implementing the least amount of code to pass each test, we keep our code dry, we keep our code refactored. By approaching each piece of our project's functionality individually, we are likely to write more modular code. Modular code is easier to maintain, update, and debug. TDD is employable. Testing is an important part of the tech industry, and many tech careers rely on it, ranging from developers and QA testers to DevOps specialists and site reliability engineers. TDD is a very, very employable skill. And finally, thank you very much for staying to the end. I really do appreciate it. You are a legend. We as CodeDynasty Studios really do appreciate your time. We appreciate you spending your time with us today. Once again, this is CodeDynasty Studios. My name personally is Dynasty, and I've been the one introducing this tutorial to you from the beginning to the end. And see you in the next video.